Hello students, welcome to your channel. Please like, share and subscribe your own channel, School Studies. School Studies is pleased to announce the launch of our educational website, Patel Section. After years of hard work and dedication, we are delighted to officially announce the launch. Our goal with this website is to provide our students with an easier way to learn their lesson and prepare for exams. The new website is interactive and gives better access to NCERT solution, GSEB solution, Kids Zone and general knowledge courses and quiz. We will be constantly updating our content with helpful information, articles, blogs, newsletters and new course announcements. We hope you find the new website with a fresh look, easy to access information. For any question, suggestion, feedback or comments, please contact us today. Today we will see a video related to NCERT solution for class 10 mathematics chapter 1 real numbers exercise 1.1. So let's solve textbook exercise 1.1. The first question is use Euclid's division algorithm to find the HCF of. So we have to find the HCF of 135 and 225. So 135 and 225. As you can see from the question, 225 is greater than 135. Therefore, by Euclid's division algorithm, we have 225 equals to 135 into 1 plus 90. Now, reminder, 90 not equals to 0. But thus, again using division lemma for 90, we get 135 equals to 90 into 1 plus 45. Again, 45 not equals to 0. Repeating the above step for 45, we get 90 equals to 45 into 2 plus 0. So, the remainder is now 0. So, our method stops here. Since the last step, the divisor is 45. Therefore, HCF 225 and 135. The HCF of 135 and 90 and the HCF of 90 and 45 is 45. Hence, the HCF of 225 and 135 is 45. Next, 196 and 38,220. In this question, 38,220 is more greater than 196. Therefore, by applying Euclid's division algorithm and taking 38,220 as divisor, we get 38,220 equals to 196 into 195 plus 0. So we have already got the remainder as 0 here. Therefore, the HCF is 196. Next, 867 and 255. As we know, 867 is greater than 255. Let us now apply the method. So 867 equals to 255 into 3 plus 102. Now the remainder is 102, which is not equals to 0. Therefore, taking 255 as divisor and applying the division lemma method, we get 255 equals to 102 into 2 plus 51. Again, the 51 is not equals to 0. Now 102 is the new divisor. So repeating the same step, we get 102 equals to 51 into 2 plus 0. So now we get the remainder as 0. So our procedure stops here. Since in the last step, the divisor is 51. Therefore, the HCF is 51. Next, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is the sum integer. So let A be any positive integer and b equals to 6. Okay, so by using the Euclid's formula, A equals to 6q plus r for some integer q greater than or not equal greater than equals to 0 and r equals to 0, 1, 2, 3, 4, 5, because 0 smaller than r smaller than 6. Now substituting the value of r, we get, if r equals to 0, then a equals to 6q. Similarly, for r 1, 2, 3, 4 and 5, the value of a is 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5 respectively. If a equals to 6q, 6q plus 2, 6q plus 4, then a is an even number and divisible by 2. A positive integer can either even or odd. Therefore, any positive odd integer is of the form of 6q plus 1, 6q plus 3 and 6q plus 5, where q is some integer. Next, army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So number of army contingents members, it's 616. Number of army bands members is 32. If the two groups have to march in the same column, we have to find out the highest common factor between the two groups. So HCF of 616 and 32 gives the maximum number of columns in each they can march. So by using the Euclid's algorithm to find their HCF, we get, since 616 is greater than 32, therefore 616 equals to 32 plus into 19 plus 8. Here 8 is not 0, therefore taking 32 as new divisor, we have 32 equals to 8 into 4 plus 0. Now we have got the remainder as 0, therefore HCF is 8. Hence the maximum number of columns in which they can march is 8. By Euclid's division lemma, to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Let x be any positive integer and y equals to 3. By Euclid's division algorithm, then x equals to 3q plus r for some integer q not greater than equals to 0 and r equals to 0, 1, 2 and r not greater than equals to 0 and r is smaller than 3. Therefore x equals to 3q plus 1 and 3q plus 2. Now as per the question given, by squaring both the sides, we get x square equals to 3q whole square equals to 9pq whole square equals to 3 into 3q whole square. Let 3q whole square equals to m. Therefore, x square equals to 3m. X square equals to 3q plus 1 whole square equals to 3q whole square plus 1 square plus 2 into 3q plus 1. So here it is the formula of a square plus b square. Sorry, a plus b whole square. So it is 9q whole square plus 1 plus 6q. So we will take the 3 common. So 3q square plus 2q plus 1. Substitute 3q square plus 2q equals to m to get x square equals to 3m plus 1. That is the second result. Now x square 3q plus 2 whole square equals to 3q whole square plus 2 square plus 2 into 3q into 2 equals to 3q whole square plus 4 plus 12q equals to 3 bracket 3q whole square plus 4q plus 1 bracket close plus 1. Now again substitute. So we will substitute this 3q whole square plus 4q plus 1 equals to m to get x square equals to 3m plus 1. This is the third result. Hence from equation 1, 2 and 3 we can say that the square of any positive integer is either in the form of 3m or 3m plus 1 for some integer m. Next, using Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 and 9m plus 8. So let x be the any positive integer and y equals to 3. By Euclid's division algorithm, then x equals to 3q plus r, where q is not greater than equals to 0 and r equals to 0, 1, 2 and r not equals to greater than 0 and r is less than 3. Therefore, by putting the value of r, we get x equals to 3q or x equals to 3q plus 1 or x equals to 3q plus 2. Now, by taking the cube of all three above expression, we get when r equals to 0, then x square equals to 3q whole cube. So that is 27pq whole cube. We will take 9 common, so 3q whole cube equals to 9m, where m equals to 3q cube. Next, case 2, when r equals to 1, then x cube 3q plus 1 whole cube. So we will put the formula of cube, so 3q whole cube plus 1 whole cube plus 3 into 3 cube into 1 bracket 3q plus 1. So that is 27q cube plus 1 plus 27p q square plus 9q. By taking 9 as common factor, we get x cube equals to 9, 3q cube plus 3q square plus q plus 1. Putting m, we get x cube equals to 9m plus 1. Next, when r equals to 2, then q cube plus 3q plus 2 whole cube. So we will put the formula of cube. So we will get 27q cube plus 54q square plus 36q plus 8. Taking 9 as common factor, we get. So we will take the 9 as common factor. So we will get in the bracket 3q cube plus 6q square plus 4q bracket close plus 8. Now we will put the value of m. So q cube equals to 9m plus 8. Therefore, from all the three cases explained above, is to prove that the cube of any positive integer is in the form of 9m, 9m plus 1 or 9m plus 8. So this was chapter 1, exercise 1.1 of NCERT solution for class 10th mathematics. I hope you like my video. Thanks for watching my video. Thank you. Please leave comment, question or doubts in comment section if you have any, or you can drop a mail to us. You will find my email ID at the end of this video. You can join us on Facebook page, follow us on Instagram, connect us on LinkedIn or tweet us on Twitter. Thanks for watching my video. Thank you.